A second way of quantifying the change in a variable is through a percentage change. The two examples on this page will help you understand the relationship between percentage change and the total change in a variable. Let's go ahead and look at example 2.9. Suppose the population of a city a few years ago was 20,000. Since then, the population has grown by 30%. Determine the total change in the population. In other words, how much has the population grown in terms of people? In order to calculate the total change in the population, we have to calculate 30% of 20,000. That's how many new people will be in this city. This is the growth of the city in terms of people. To calculate 30% of 20,000, we convert the 30% into a decimal. That's 0.3, and we multiply it by 20,000. If we work this out on our calculator, we find that we arrive at 6,000 people. Let's look at example 2.10. Suppose the population of a city a few years ago was 50,000, and since then the population has decreased by 15%. In other words, the population has lost 15% of its residents. Determine the total change in the population. Be mindful here that the total change has to be negative because the population has decreased. So let's go ahead and figure out what the total change must have been. How many people were lost? Well, we're told that the population lost 15%. So the number lost must have been 15% of the 50,000. If we calculate this, that is a positive quantity. But total change, because the population is decreasing, the total change must be negative. So once I calculate this quantity, I'm going to put a negative in front of it. To calculate the quantity, I convert 15% into its decimal representation, and then I multiply by 50,000. If I work this out on a calculator, I arrive at negative 7,500. In other words, the population lost 7,500 people. The examples above illustrate the relationship between the percentage change of a variable and the total change of a variable. Next, we'll summarize this relationship. In general, suppose the starting value of a variable v is v1 and that the value of v increases or decreases by p%. This is precisely what we saw on the previous page. We calculate the total change, in other words, delta v, by calculating p% of v1. We calculate p% of v1 by taking the decimal representation of the percentage change and multiplying it by v1. Now, there are two important points to note here. First of all, we will assume that a percentage increase is represented by a positive value of v, and a percentage decrease is represented by a negative value of p. This allows us to be consistent with the idea of total change being positive when a variable increases and being negative when the variable decreases. Let's go ahead and look at this equation here. If the variable v increases, then p will be a positive decimal, and this quantity here will also be positive, therefore the total change will be positive. On the other hand, if v was decreasing, we would say that this decimal, P, is negative. That will make the entire quantity negative, which will give us a negative total change. In the examples on the previous page, when the population grew 30%, we would say P is 0.3. In the example where the population decayed by 15%, we would say that P is negative 0.15. Now the second point. This equation above is useful whenever you're trying to determine the total change. Frequently, however, we know what the starting value and the ending value of a variable is, and we're asked, what is the percentage increase or what is the percentage decrease? In other words, we want to know what is P, or more specifically, what is P%. In situations like that, we can still use this equation, but we need to have it solved for P. If P times V1 is equal to delta V, then P must equal delta V divided by V1. That is the equation you see below. This equation enables us to determine a percentage change if we know the starting and ending value of a variable. This is illustrated in the following example. Let's look at example 2.11. Suppose the value of a variable has increased from 12 to 15. Determine the total change in this variable y. In other words, let's determine delta y. Delta y, remember, the total change in y is found by taking the ending value and subtracting the starting value. In this case, the ending value is 15, the starting value is 12, and when we subtract, we get 3. In other words, y increased by 3 units. Now, by what percentage has the value of y grown? That is where we can use this equation. To calculate the percentage growth, first we can calculate the decimal representation. We take the total change in y and we divide by the starting value of y. The total change is what we calculated in part A, namely the 3. The starting value of y is the 12. When we reduce this fraction to lowest terms, it's 1/4, or as a decimal, 0.25. If we translate this into a percentage, we find we get 25%. In other words, when the variable y increased from 12 to 15, the value increased by 25%. Let's go ahead and look at the next example. The amount of primary forest in Brazil has decreased from 4.61 times 10 to the 8 hectares to 4.16 times 10 to the 8 hectares between the years 1990 and 2005. So in this example, what is the variable? That's the first question that you would need to recognize. In order to answer this question, you have to think about what has changed. And in this example, the thing that's changed is the amount of primary forest. So that's the variable. Now, how much did it change by? In other words, what's the total change in the forest area? The total change, as always, is calculated by taking the ending value and subtracting the starting value. In this case, the ending value is 4.16 times 10 to the 8, and the starting value is 4.61 times 10 to the 8. So we are subtracting two very large numbers here. Since both of these numbers are written in terms of 10 to the 8th, there's a rather easy way of subtracting them. We can simply take 4.16 and subtract 4.61 from that, and then take our answer and multiply that by 10 to the 8. In this case, when we do this, we get negative 0.45 times 10 to the 8 hectares. That is the change in the number in the amount of forested area in Brazil during this time period. It's negative because the amount of forested area decreased. Negative 0.45 times 10 to the 8. It's a large number. To give you some context of how large that is, 0.45 times 10 to the 8 can be rewritten as 45 times 10 to the 6. In other words, 45 million hectares of land. Let's look at part C. By what percentage has the forested area dropped? Give your answer rounded to the nearest percentage point. To calculate the percentage decrease, let's first of all calculate the decimal representation of the percentage, little p. This is calculated by taking the total change in a variable and dividing by the initial value of the variable. We calculated the total change in part B, namely negative 0.45 times 10 to the 8. And the initial value of V would refer to the initial amount of forested area in the year 1990, which was 4.61 times 10 to the 8. We need to simplify this fraction. In this case, notice that there's a common factor of 10 to the 8th in the numerator and the denominator. These can be canceled. The remainder of the fraction can be simplified using your calculator. Don't forget the negative. When we put this into our calculator, we arrive at a decimal of 0.098 when rounded to 3 decimal places. Now we can calculate the percentage change. I'm going to incorporate the negative so that we don't lose track of the fact that this is a decrease. And if I move the decimal point 2 places to the right, we arrive at 9.8%, which, when rounded to the nearest whole percentage point, gives us a negative 10%. Interpreting this, we see that there is a 10% decrease in the forested area in Brazil during this time period.